welcome back. First thing first, we have a new team member, Chris Gerber. So some of you probably already heard from him as he being your point person, but he's here to help. Second, don't forget that your project is due next Wednesday. So we are diving into iOS/Objective-C today, but you still need to keep up with your project that still has to do with JavaScript and HTML. Okay, so first we're going to recommend some books. David always recommends this one. You're going to want to make sure that your book is up to date with all the new iOS versions. So iOS 7, it was a very recent development. We are only going to be dealing with iOS 6, plus I think iOS 7 isn't like officially available for a couple months. So iOS 6 is what you're going to want to be using. When you start going back versions of iOS, things start changing pretty significantly. You don't want to go back to like iOS 4 or before because things are going to be substantially different. So look for iOS 6 things. Another book that I've never actually looked at, but is supposedly also pretty good, is this one. And I added this slide just before because this is the one I actually use just to catch myself up with everything. It's a free preview of a book, and I found it to be pretty good. I feel obligated to say, like he does at the top of the page, that if you found it useful, you might want to consider actually buying the book. But that pretty much everything is in here. Okay, so before we get into Objective-C, we first need to touch on C. So it's important to remember that Objective-C is a proper superset of regular C. So like any Objective-C program that you write, you could write valid C all throughout the Objective-C program. Well, not literally everywhere, but everything you know from C is still applicable in Objective-C. So first, show of hands, who knows C or any C? All right, that's better than I was anticipating. And another show of hands, who has any experience with any object-oriented language? All right, cool. So we'll do a really quick intro to C just to refresh you on everything. You'll probably recognize that a lot of it is pretty similar to JavaScript, so it's probably still pretty fresh. So your very standard hello world program. What does hash include standard.io.h do? What is standard.io.h? I think I might have heard someone say it, but it's a header file. It literally just contains like, we'll see like the declarations of the functions. So we'll see more examples of those later. Those are still going to be pretty important in Objective-C. Here we see we are declaring our main function. So just like in C we declare a main function, in Objective-C you are also going to have a main function. And what are these guys? Int argc and const char star argv. What are those? Command line arguments. So int argc is how many arguments were passed at the command line, and const char star argv are what those arguments were. And then we just printf. We'll see that once we get to Objective-C, we're not going to really be using printf anymore, but pretty standard program. So statements, that is a statement. Variables, you just declare them int n, or you could say int n equals 0. That's going to be the same when we get to Objective-C. We have all of our regular primitive data types, char, double, float, int, long, and then the modifiers like unsigned int and unsigned double. And printf, so if let's go into, we'll have a whole bunch of example programs up, and we have a whole bunch in C and Objective-C. We're not going to go through all of the C ones because a lot of them will just be tedious. But if you feel you need a refresher, you can just go back and look at all these. So we'll look at the first C one, hello C. Okay, so this is what we just saw before up there. And printf, remember, takes these modifiers, such as %s, that are going to then be a comma-separated list of things at the end of the printf call that you're going to fill in. So like %s, it's expecting a string to fill in that %s. And if instead we did int n equals 50, then we could do %d and pass in the variable n. So that's how we're going to use printf that's how we print variables. And you'll see that these format specifiers, this %s and this %d for integer, those are going to carry over into some Objective-C areas. Plus, all of these primitive data types, remember that Objective-C is a superset of C. These still exist. Yeah.
Can you show that link to the book, the internet book?
I'll go back.
You did it too fast.
The slide will be online later, but if you want to look it up now.
Thank you.
Yeah. And feel free to stop me at any point with questions. Good? Okay. Okay. So the Boolean expressions, the very simple ones that you should all be used to at this point. Conditions, we have our regular if-elses. Loops, we have for loops. So in JavaScript, you also have the for in. You'll also see that in Objective-C. Regular C does not have that. So we have our regular for loop, regular while loop, regular do while. And all of those will still be usable in Objective-C. So casting is an interesting case where it's exactly the same between C and Objective-C, but you're going to see you might be needing it a lot more once you get to Objective-C. So in C, there are only so many cases I can possibly think of where I want to cast. Like one example is if I want to do 3 divided by 5. You know how if we just do the integers, then 3 divided by 5 is going to be 0. So I might want to cast 3 to a float so that it actually does floating point division. So that's one scenario I can think of where I want to cast. Once we get to Objective-C and we start dealing with classes and things, then we're going to want to cast, we'll see more of this, but super types to subtypes and subtypes to supertypes. So casting, you'll want to be comfortable with it. And then pointers, they won't be as important in Objective-C, but you're still going to have to deal with them. So we have just the type of a pointer. Let's actually look just as an example. All right, we'll go over the typical example of a swap function. That here, so this line, like I hinted at before, this swap line is the function's prototype. So those are the sorts of things that we'll see in header files like standard.io.h. We'll also see struct definitions. We'll get to structs. We'll see hash-defined things. So here in main, we declare a variable x and a variable y, and then we print x, print y, and now we want to swap x and y. So ideally, after this swap line, x will have the value 1 and y will have the value 0. They will have swapped values. And I won't actually run it, but trust me when I say that this will not succeed. Looking at the actual swap function, we see it takes a and b, so we're passing x for a and y for b. We then store a in a temporary variable, put b into a, and put the original a into b. So why this doesn't work is it's important to remember that everything in C, when you pass it to a function, it's always a copy of the thing being passed. And so here, what we're actually passing to a swap is a copy of the value 0 and a copy of the value 1. And so down in the swap function, when we say a equals b, we're just modifying the copy of those values. We're not modifying the original x and y. So here's where pointers become important. So here, notice the function prototype has changed. We now are passing int star a. So as soon as you see int star or char star or anything star, you know you're dealing with a pointer. And coming down here, we're no longer passing x and y, we're passing ampersand x and ampersand y. So ampersand, I usually read literally as address of. So we're passing the address of x, and we're passing the address of y. And so, and it's since x is an int, then when you get the address of an int, the type of that address is an int star. If we had a char and we put an ampersand before it, then we would have a char star. So coming down into the swap function, again, this is going to take an int star and an int star. And here, it's unfortunately somewhat confusing that there are two uses for the star. The first use for the star is to declare something as a pointer type. So when you see int star b, you know that b is a pointer to an integer. When you do not see a type, like right here, when you say star a, we are dereferencing that pointer. So if b points to y and a points to x, then star a is referencing the original x. And so temp is going to store the original value of x. Star a equals star b. We're going to go to the original value of x, like the original x, and we're going to store there the original y. And so x has actually been changed now. And here we're doing the same thing. We're going to y and storing the original value of x. Questions? Okay. So in Objective-C, a lot of this is going to be, you won't be needing to do as many explicit dereferences, but it's important to remember that when you're passing these things, that objects themselves are pretty much like pointers. And so if like you pass an object to a function, and in that function you modify the object, the original object will have been modified. And we're going to see that. And just for fun, I threw in the end that char star star is also an example of a pointer. It just happens to be a pointer that points to a pointer that points to a char. So a good example of that is just our command line arguments, argv. So ignoring the fact that it's bracket syntax, there are some, this isn't entirely true, but in a lot of scenarios, arrays and pointers are pretty much equivalent. So const char star argv bracket, we could have also said as const char star star argv, which makes sense since argv is an array of strings, and we represent a string as a pointer to a single character. Questions? Okay, so structs. So it'll be important to actually remember structs because you will still be dealing with them in Objective-C, and a lot of the iOS code will be dealing with some structs. Unfortunately, it can be somewhat confusing because you might forget when you're dealing with a struct versus an object since they are different. But let's look at an example of using a struct. Remember, struct is pure C, and objects are Objective-C. Yes?
Do you have a structure of objects?
So you can, once we get to Objective-C, you can, yes. It's, a struct is literally just a wrapper for a group of variables. So if you can have a variable point to an object, then you can store that variable in a struct just as well. Looking at a struct example that doesn't use objects. We see here this typedef struct student. So the only reason for the typedef is so that, then we technically need to put student here, but the only reason for the typedef is so that whenever we want to declare a variable of this struct type, if we just do this, now we have to say struct student x and struct student y. So the typedef just saves us that. And now we can just say struct student, or now we can just say student x and student y. So what is inside of this struct? We have an age and we have a name. And so these are exactly what structs will look like in Objective-C. And coming down here, we see we declare a variable of this struct type, Alice. And we're going to use dot notation to access the fields in that struct. So Alice.age equals 20, and Alice.name equals Alice. Then we can do the same thing. We just declare Bob. And that's pretty much like everything about structs that you will need. So questions? Oh, and then if you want to look at the greet function. Up here, we are storing inside of bob.age21. And down here, we are accessing bob.age. Okay. Next, we will also have enums, which are somewhat more important in Objective-C than they were in perhaps you've used in regular C, since there's a lot of code you'll be working with uses a lot of enums. So what does an enum look like? So it's like a struct, and again, we're just using typedef so that when we want to declare a variable of this enum type, we don't have to say enum genders x and enum genders y. Thanks to the typedef, we can just say genders x and genders y. So enums aren't strictly necessary. We could instead do hash define female as 0 and hash define male as 1, and hash define just declares this to be a constant. So right now, if I got rid of this, the two programs would be almost equivalent, except for the fact that I just got rid of the genders type. So why do we prefer enums over these hash defines? Because if I add a whole bunch of hash defines, something 2, something 3, something 4, and then I decide to like reorder them, then I would have to like change the numbers on all the rest of them. And also, it's just a convenient way that I don't have to explicitly list the numbers on all these things. Once we get to Objective-C, and I think more specifically Xcode, there's also some, well, it's coming down here. We see that we have changed this struct to now it takes a name and a gender. So Alice is going to be given the name Alice, and is going to be given the gender female. So it's important to remember in C and also Objective-C that there is no enforcement of the gender's type. So I am just as easily able to put 100 underneath the hood, and enum is literally just an integer. So even though 100 is not a valid genders, it will let me do this. But in Xcode, generally it will yell at you like visually if you're using things that aren't correct enum types. So you'll want to use these enums correctly. And that's pretty much it for enums. Questions? Okay. So then arrays. Regular C arrays are still going to work in Objective-C. You're also going to see that there are these new array classes that you're probably going to want to get used to, so you might not be using them that much. Just to look at an example of using the arrays. So here, we declare a variable int n. We print enter number of exams. And then scanf is just a way of grabbing input from the keyboard. So here we are scanfing for some integer. This %d carries over from printf. It's looking for an integer. And why do we need to pass ampersand n and not just n? Why would this never work? Yeah. So inside of the scanf function, just like we saw before with the swap function, ideally, after this point in time, n equals whatever number I typed at the keyboard. So scanf needs to actually change this n. Scanf can't change that without a pointer to that n, without having the address of that n. Otherwise, if I just did this, then, well, first it wouldn't compile. But assuming it did accept that, it would just try to set the local variable n to the keyboard entered value, and this n would remain unchanged. So we need to pass the address. Here we are declaring an array, and that array is going to be of size n, so we're going to have n integers. And this is all going on the stack so far. And then we're iterating over the n values, entering a grade into each individual spot in the array. So really, this program is going to behave like, how many grades do you want to enter? 3. What is the first grade? What is the second grade? What is the third grade? So you enter each grade. And also, we have to pass, so grades I is the ith position in the array, and then we also need to pass that by reference. We need to pass the pointer to grades I for the same reason that we needed to pass the pointer to n. Questions? Okay, so memory management. It's one of the bigger problems in C, and for the most part, you aren't going to have to deal with it in Objective-C. There are some small things you'll have to think about, and we'll get to that next week, but the malloc and free stuff that you're used to, you don't really have to deal with. So remember that we have our stack and our heap, and so all of our local variables are always stored on the stack. And this means that, say I call some function, and it needs to like return some array to the function that called it. It can't just declare an array on the stack and return it, because once the function returns, that array is gone. That's the point of it being a local variable. The array is gone. So malloc, what that does is allocate space on the heap, and the stuff that's allocated on the heap survives past whenever the function happens to end, whenever that variable happens to go out of scope. And so what malloc and free are like manual memory management versus the automatic memory management of local variables. And something to keep in mind is that pretty much all objects are going to be like this. All objects are going to pretty much be malloced. They're going to go on the heap. And so they're going to continue existing after the scope of that variable ends. But thanks to the new iOS Objective-C features, you don't really have to think about freeing that memory. So we'll see why that's really useful.
Does that mean iOS is garbage collecting?
Yes. So the new, it's ARC, A-R-C, is automatic reference counting, and it will automatically collect these objects for you. That was not the case 2 or 3 years ago. Yeah?
Maybe give an example of a time
When you don't want to use ARC? So the only thing I could really think of is like if you wanted to be really explicit about the, like, you want to fine-tune your program, overly optimize it to make it like run better, but that's probably not the best use of your time. You are already using Objective-C, which there are a lot of things that's not doing in the most optimized way possible. So pretty much any app nowadays is going to use ARC.
I was thinking in a way that like maybe would make your application more performant.
Oh, so an example.
Maybe like memory-intensive, like graphical games apps.
It probably would, but it's not really worth even trying to optimize your app for that. Yeah.
If I use, for some weird reason, malloc manually in my iOS program, does ARC catch that too? Or?
No, it will not. You pretty much shouldn't be mallocing. I actually wonder, I'm not 100% sure, but I imagine it's already taking very strict control of what the heap looks like. And so if you start mallocing things on top of what it's trying to do with the heap, it might screw it up, but I'm not sure. You won't need to malloc. Okay. Objective-C. So C questions before we move on to Objective-C stuff. Yeah?
What about
Oh, so that's, well, in C, you would need to use free. So anything you malloc, at some point during the life of your program, you should also free. In Objective-C, that's the thing. So things are going to be somewhat automatically allocated for you, and they will be automatically deallocated for you, as long as you adhere to some things we'll see next week. OK, any other questions about C before some Objective-C stuff? OK, so from our hello world in C to our hello world in Objective-C, there aren't too many changes. You'll see that it looks a lot like C in a lot of ways. Unfortunately, the first word has literally changed. So what do you think the difference is between include, like we used to say hash include, now we say hash import. So what do you think the difference is there? So hash import is smarter than hash include in that it will only import something exactly once. And so this used to be an issue with hash includes. Like if you hash include a header file twice and you don't take special precautions in that header file, then you might duplicate some definitions of things and it won't compile. Hash import, no matter how, if I said hash import foundation dot, or like if I just copy and pasted this line, the second line wouldn't do anything. So hash import is just going to be more efficient in that way. And another thing that looks somewhat different is this @symbol auto release pool. So that's going to be something we deal with next week. That has to do with automatic memory management. And the one thing to note, and we'll also see it in front of the hello world, this @ symbol is a very Objective-C thing. So like if you see code and you see an @ symbol, you might be able to reason that it is Objective-C because you're going to see this all over the place. In case of the hello world, so normally we'd see just like string hello world. By putting the @ symbol in front of it, we are making it an Objective-C type string. More explicitly, we are making it an NS string. So we're going to see that in a couple other places. But now this @hello world is an object that we are passing to the nslog function. Let's actually run that. So what is the ridiculous? Oh, I have you. So you will pretty much never need to compile at the command line. Because once we get into Xcode, that's going to pretty much be everything you need. But here, we have compiled that program. It's exactly the same as the one that we saw in the slide. And running it, we see something that looks like this. So we see the date, we see the time, we see main, and then this happens to be the process ID, and then something called the mock port that you don't have to care about at all, and then the actual thing that we NSLogged. So this is what NSLog does. You will probably be using NSLog pretty frequently in your programs to debug things. In actual released apps, you probably want to get rid of your NSLogs or have them wrapped in like debug type statements. Since once you're on an iPhone, you pretty much don't have access to anything that is NSLogged. I think theoretically you can like plug in your iPhone to your computer and see what was NSLogged, but that's rare. Like anything released to the App Store isn't going to have any of those. Okay, so this is our first exposure to an object, but it doesn't really feel like an object because we pretty much just put an @ sign in front of it. That's technically shorthand for creating a string object, and I think we'll see the longhand later, or we'll at least see many other objects that we're going to be creating. So useless slide that just says everything so far has been the command line. Everything can be done at the command line. You probably won't want to do things at the command line. So Xcode is pretty comprehensive on all things Objective-C and iOS. you should be able to get it for free. And we aren't really going to go into the details of what all these different places in Xcode are. It's pretty overwhelming the first time you see it. The only things we're going to be using today, like it's going to look like 3 of them. So we're not going to be using utility area. The debug area is what we're going to use to see where our NSLog things are going to be printing. The editor area is where we're going to see our code. And navigator area, we're just going to see our files. And it also contains all this debugging support and stuff, but we're not going to go into that. So you could, if you have an iOS device and you want to actually install these apps to your iOS device, this was discussed last week, but you need a developer account. So through us, you can get a free account, but you are not able to actually put the things in the App Store. So if you want to put things on the App Store, you will want to get your own account, which is $99 for yourself, and I think like $299 for a company or something. So you can look up a lot more there. And these will be put online later. So the new data types in Objective-C, there's pretty much only 2 big primitive data types that you need to care about. So bool and ID. So a bool is like a bool in every other language. Unfortunately, it is not true and false. It is yes and no. So you're going to be seeing a lot of capital yeses and capital nos in your programs. I think the reason for that is once we start seeing functions, the way the functions are worded, it's kind of like, and do you want this? Yes. And do you want this? No. ID. So if you're more familiar with C and you know what void star is, ID is sort of like that, but for objects. ID just sort of represents like a generic object. You don't know what the type of the object is, but you know that this thing is an object. And nil is sort of the counterpart of null. So nil represents a non-existent object, but it has some special properties. Questions? Okay, so here are some data types that if you saw when we hash imported foundation/foundation.h, which pretty much everything you're going to be doing is going to do. We also get some of these data types, NSInteger, NSPoint, NSRect. These are not objects, and this can be somewhat confusing because it can be somewhat difficult to differentiate between objects and just these type-def things. So they exist for various like legacy reasons, and so like NSInteger exists as sort of this weird bridge between 32-bit and 64-bit, and pretty much use it whenever, like when you're looking at documentation and you see that this function returns an NSInteger, use an NSInteger variable. So none of these are object types. But now, just a quick discussion about what classes and objects are, in case you don't have any object-oriented experience. So we're going to be defining classes today. And a class, it's going to be similar in Objective-C to other languages you've seen. A class is going to define methods and variables. And it's pretty much a blueprint that then objects you're going to create from those classes. So class is going to say, like, any object of this class should have these variables and these methods. And then it's on those objects that, or in those objects, you're actually going to have those variables. So you have a single class, and many, many objects can come from that single class. It's also important to remember that in object-oriented programming, classes, you're going to have this hierarchical relationship that we're going to be seeing. So like if I define, well, in Java, you might have seen like the object class. In Objective-C, the equivalent is NSObject. So everything, almost everything, in some way inherits from this NSObject class. And so if I define some class person that inherits from NSObject, then I might define another class, student, that inherits from person, and then I might define some other class, 8th grader, that inherits from student. So remember that these classes have these hierarchical relationships, And this is important when you're looking through the documentation, because if I look at some random, like if I look at the Apple documentation for the 8th grader class, and it shows me like the method spelling homework, you might think that's the only method it has, but it has a lot more methods than that because it also inherits all of the methods from all of its parent classes. So you need to look through the hierarchy to know all the methods everything has. Questions? Okay, so .h files. Unfortunately, the interface keyword is somewhat different from what you might think of as like a Java interface and some other languages' interfaces. It's still similar in that you're going to be defining, like, you're just going to list the prototypes of the methods that you want to be in this class. But we'll see later this thing, protocols, and those are going to be more like the interfaces you're used to in other languages. So in .h files, we have this at interface, and so at, as usual, telling us it's Objective-C. So at interface, and this class is going to be called foo, and then this colon indicates the class that we are inheriting from. So our parent is going to be NSObject. And then this ugly syntax where we put curly braces and then instance variables go in the curly braces. And then underneath the curly braces, we declare all the methods that this class needs to define. And we'll see plenty of examples of those. And then getting into .m files. So pretty much every .m file is going to have its corresponding .h file. Inside of the .m file, we give the implementation of these things. And so here we're going to give the implementation of foo and actually define all the methods that in this .h file we said we would define. Okay, so we'll look at an example. And this time we'll do it in Xcode. Actually, all right. So here we see on this left side we have all our files. I'm going to get rid of this right side because we don't need it now. Up in the down at the bottom, we're going to have our nslog stuff down here. So looking through these files, I'm not going to be able to do that. So looking through these files, we see we have a main function. We have this same auto release pool thing that you can ignore for now. And then we're going to have this student star Alice. So student, we see over here, is going to be an object. We have a .h file and a .m file for it. We'll look at those in a second. Student star, so I guess I'll go into that. Ignore this for a second. So just student star Alice, we're going to allocate the student. So this is sort of like malloc. So we're making room for this student. And then apparently we have some age field and some name field. Let's actually look at it. So here's student.h. And we have interface student. It's inheriting from NSObject. And here we see this at public keyword. This tells us that everything underneath, all the variables underneath this word are going to be public instance variables. There's also at protected and at private. So private, no other class is going to be able to see these variables. And protected, any class that is a subclass of this class is going to be able to access these variables. So you won't need to deal with those too much. Generally, you want to make the access to these variables as tight as possible. So like if the variables can be private, make them private. So here, the instance variables we have are age and name, which is an NS string star. And we see since there are no methods defined down here, that means that, well, let's look at it. Student.m doesn't need to define any methods. Yes?
So why we use integer here instead of NS integer?
Why did we use what?
Because we use NS as string, why we don't just use string here?
Oh, so we could use string or just char star, like a regular C type string. But in Objective-C, you're going to be passing around these NS strings a lot. So you're probably going to want this thing to be an NS string. Like when we want to actually print this, we're going to need to print an NS string. We can't, or when we want to NS log something, we need to NS log objects. So we're going to need to pass it an NS string. We can't pass it a char star. We would have to change that char star to an NS string.
But we also have NS integer.
Yeah, so NS integer is, this is where it's, NS integer is pretty much going to be just a typedef for regular int, or possibly long. This is not an object type. This is not a class. This is just like typedef, NS integer, int. So this is why like these aren't that helpful unless you see that a function in the documentation is returning an NS integer, and then you should use NS integers.
So these NS something objects, they can be primitive values and object values.
Yes, so that's the unfortunate thing. You get pretty, like, the primitive ones are this NS, well, actually, no, I can't even say that. There are some complicated ones that are primitive, and I wish they had done something to differentiate better, but they didn't. And let's change this back to int, but it shouldn't change anything. So in main, so we are now accessing this. So student star Alice is an object. That object has an age field and a name field, and we are accessing those and setting the age field to 20, and we're setting the name field to be this NS string Alice. Note that this would not succeed without the @ because now it's not an NS string and it yells at us appropriately. And in case you're curious, this arrow syntax, it comes more from C. Come the next example that I give, you will not be using this arrow syntax. But what it is, so we're treating Alice sort of as like a struct. And so we are dereferencing that struct and then accessing the age field inside of that struct. So arrow is equivalent to star Alice dot. This is just a very disgusting syntax, and so that's why they give us arrow. Arrow just means here is a pointer to a struct/object, and go to that object and change this field at that object. But you will not be using arrows on objects ever. So this is a pretty bad example, but this is our intro example. Do the same thing with Bob. We allocate him, we give him an age, we give him a name. And then greet down here, we're going to nslog, and we see nslog, and we need to pass nslog and nsstring as its first argument. And so we see our normal %d over here, and sage is just, as we saw in the student.h file, sage is just an int, and so that's fine. And sname was an ns string, and so the nslog version of like %s for ns strings is going to be this %at. So that is the flag for printing ns strings. Actually running this, so up top, hitting build or run, I forget the shortcut for it, and down here we see the nslog output. Hello Alice, you're 20. Hi Bob, you're 21. Questions on this simple example? Because it's going to be changing pretty substantially in the next example. Yeah, so this is also what I kind of paused at before because I didn't want to say quite yet. Student star. Student is really like, Alice is the object, but like pretty much read student star. Don't read that as a pointer to a student. Just take student star to be like the type of the object. So you will never really be dealing with a student Alice. You will always be dealing with a student star Alice. And in the next example, going to students 2.
So with Objective-C, it's not possible to do global objects that go out of scope when the function goes out of scope.
No, not really. Okay, so in this example, let's look at .h first. So now, this is the same. It's inheriting from NSObject. We have changed this. We're no longer saying int age and a string name. We're saying underscore age and underscore name. And that is a convention that in the past it used to just be a convention, and now it's a convention that actually means something. So you're going to want to pretty much always have these instance variables be underscored. And now here we're getting to these strange looking method things. So let's actually go back to slides for a second. We'll see in a second why we want the underscores. I haven't quite gotten there yet. Okay, so instance variables, we saw we can have them at protected, at private, at public. And it's somewhat messy, but like when I said at public, everything beneath the at public would be public. But then if I switch to, like if I had at public int x, then at private int y, y would be private because it's underneath the private. Okay, so first let's look at this. So messages. In other object-oriented languages, you don't really, well, some you do, but Java you don't. So messages are going to be the way that we invoke methods on objects and classes. So here, this square bracket syntax is what you're going to be using to send messages. And here we're saying the student class has a method called alloc. And so send to the student class that method, invoke that method, and then that is supposed to return a student star. And so this alloc is going to be pretty much everywhere. Whenever you need to allocate an object, you need to do some sort of alloc. Sometimes there's like alloc. Sometimes there are some other alloc type functions you might be using, but you're almost always going to be allocing these things. So here, so there are two different types of methods, like there are in other object-oriented languages. So we have instance methods and class methods. And so the way we're going to differentiate between those is all the way on the left side, you see we have this minus sign. So if we have a minus sign, that means the method is going to be an instance method. And if we have a plus sign, that means that it's going to be a class method. And an instance method is something that you actually need an object to use the method. And a class method is something where you don't need an object to use the method. So going back to here, the fact that we're calling alloc on the student class tells us that alloc is a class method because we don't actually need a student to allocate a student. That'd be pretty flawed if we couldn't actually get a student without having a student.
So if you have a plus sign, then it's like a static method.
Yes. So yeah, the static keyword from Java is the equivalent of plus. So the syntax for these things, we see all the way on the left is going to go plus or minus, always. And then we're going to have the return type of the method. So here we have void, int, void. Then after the return type, we have the name of the method. And so we have the name init and we have the name age. And then technically the name of the last method is going to be setAge:. We'll see why. But this age is what we're just going to call that variable, and this is the type of that variable. So this method isn't going to return anything. It's called setAge:, and we would pass it some integer. So sending those messages, we see that student, we're using lowercase student, so this student over here, this student object. Since these are instance methods, we need to send these messages to objects. So we send the init message to student, we send the age message to student, and then we send setAge with the parameter 20, with the argument 20. questions?
The C notation, like dash, the arrowhead in it also work? Like arrowhead in?
What do you mean?
Like if I want to call the init method on student, I can call it like that, I guess?
Yes. That is how you should call it.
And could I also call it C style?
Could you call it as what?
Like I would in C.
How would you call it in C?
Like I would say student and then a dash.
So no. This is why the previous example was something that was bad. You should very rarely be dereferencing objects. I almost want to say never dereference objects. And so the arrow operator is an implicit dereference. And so init is also somewhat different from setting the fields of the object. And another reason why the previous example was bad. You never want to deal with an object that was allocated but not initialized. So even though the student object, and we'll see in the next example how I originally just had like student alloc, and then I did Alice arrow age. I shouldn't have done that. I should have done student alloc init. So always initialize your objects, and then I could access those fields. But then on top of that, I shouldn't be accessing those fields using arrows. I should be sending messages. So we'll see that in the next example, the right way of doing that. And then we'll see that there are like 10 newer right ways of doing it. So selectors, pretty much an alternative name for method. So alloc, init, age, and set age, colon. Remember the colon is part of the name. Once we see multiple argument functions, we'll see that there will be multiple colons in the name. So all of those are just selectors, and we'll see why that's relevant later. And let's look at that example now. So student 2. Okay. So here we have said int underscore age and underscore name. And now we have 4 methods. And this is like the getters and setters of Java that you might be used to. We have 2 methods, one called age and another called set age, that the first one is going to get the age of the thing, and the second one we're going to use to set the age. And similarly down here, we have name and set name. The first we're going to use to retrieve the name, and the second we're going to use to set the name. And these are important names, both by convention, and we'll see things that help us later, where in other languages you might say like get name and set name. Here the convention is just to say name. Do not say get name. Questions? Okay. So looking at the implementation, we must be implementing these 4 methods. And so notice they are all instance methods. They are all minus. And age, we're just going to return underscore age. Set age, we're going to set underscore age. So we're going to set our instance variable age to the passed in argument age. We're going to return underscore name, and we're going to set, well, this one's somewhat interesting. So we're going to set our instance variable underscore name to name copy. So we know that this syntax is how we're going to send messages to objects. Name is an NS string object. And so apparently, and you can look in the documentation to verify this, apparently name or NS string has an instance method called copy that is going to return a copy of this NS string. And why do you think we want a copy of the NS string instead of just saying underscore name equals name? Yeah.
Well, because it's an object, you'd be modifying the pointer to that object, so you'd be modifying the initial object.
Yeah, so it isn't, well actually, so if we did not make a copy of the name, it isn't a threat that we are going to modify that NS string, since we don't have any methods for modifying that NS string. I guess if we went around the proper method protocol, we would be doing things. We'll see why we should never be modifying name, but it's possible that the NS string that was passed to us at Bob or something is that could later be changed. And so if that is changed, then if we just do this, then we are also going to, the name within this object will have been changed. So we want to copy Bob for ourselves in case if Bob is ever changed, we don't want to be changed. Okay. So looking at main.m, now this is the better way of doing this. This is like appropriate Objective-C. We're going to see there are more and more better ways, but this is at least like not bad. So we are appropriately initting, and notice that we are allowed to like nest these things. So we could, if we wanted, do student alloc and then Alice equals Alice init, but we are allowed to nest these calls. Okay, and now we are, instead of directly doing Alice arrow age equals 20, which is bad, we are saying Alice set age to 20. We are sending the message set age with the argument 20 to Alice, and we're setting the name to Alice. And similarly with Bob. And then what greet's going to do is use this sname and sage. We're going to send those getter methods to get getter messages to get the appropriate instance variables. Yeah?
Is it just a syntax convention that you're using to not also nest setting the agent?
Oh, so the only reason we can do that here is because student alloc happens to return the student object. And so we are then using that student object and initting it. And that also returns the initialized student object. Set age doesn't return the student object. If we could actually do that, we could do like, instead of void, we could have it return the student object. And then this is going to get into return self. Self is going to be our keyword here. We'll see it later.
Question for the set name. Can we just pass the illustrator value and
So here, are you saying why should we need?
the string by reference? So that's why you make a copy, but you can pass it by value.
So this is you never pass objects by value. You never handle objects as explicit values. You're always going to go through a pointer to the object, which is why I say think of like NS string star as the object, not a pointer to the object. Think of it as the object. Except that if you modify it, then it's going to be modified because it's a reference. Okay, so now we're returning self, which is going to allow us to do that nested. Now we're free to do Alice set age 20, set name Alice. Not yet. The next example we'll be able to. Just to point out one other thing that you might see in like documentation or like examples online or stuff. So alloc init is such an incredibly common thing. Like you might be doing some different initializer. There are different initializers, but using alloc and init is so common that there's actually a shortcut new. And so new is going to new is going to first allocate and then initialize. So that does it in one step. There are this is the first of 3 religious wars you'll hear today about Objective-C, that there are a lot of people who say new is a perfectly fine thing, and there are a lot of people who say you should absolutely never use new. So we don't care which you use, whether you want to explicitly allocate and then initialize or whatever. Okay? Questions on any of that? Yes?
So is allocate essentially reserving space on the heap for the object, and init is setting up the instance variables of that?
Yeah, it potentially doing other things than setting instance variables. If you wanted, you can define an initialization method that like counts the number of objects of this type that have been initialized. But you should never handle an uninitialized object. Okay, so then this is going to be the next example that we're going to want to use, but let's just look at the slide first. So property. So this is going to be what we're going to use to enable us to use dot syntax. We can somewhat ignore a lot of these keywords for now. This assign, copy, strong, weak are things we're going to deal with next week. Strong and weak in particular are pretty much the only things you really need to think about under ARC. So those are memory management difficulties that if you get those wrong, you can still leak things. But it's not too bad. It's especially better than needing to keep track of everything. Atomic and non-atomic are a different pair of things that we'll get into, and read-only and read-write we will talk about today. So at property, new thing. Let's look at the example. Student 3. Okay, so looking at student.h, the only thing that has changed is that we have added these two lines. So we have said at property, and from each of those groups that we saw on that property slide, we are picking assign from the first group, non-atomic from the second group, and read-write from the third group. And then we're saying that this instance variable is called int age. So assign, again, you can ignore. Non-atomic, this is just saying that like you can assume that we're not dealing with any multi-threaded type messiness here. You don't have to deal with the overhead of making sure that whenever we modify this age instance field, that you don't have to deal with making sure it's atomic. So atomic just means like it happens instantaneously. We don't have to deal with that. So, and read-write, this is probably, or in this class, you're pretty much only going to be using non-atomic. Read-write is one that if it's read-write, then this property is expecting a setter and a getter. If it's read-only, it's expecting just a getter. So since we want to be able to both write to age and get the age, then we say it's read-write, and similarly for name. Okay, so then these are the same. Back in student.m, we see the same. But looking at main.m, the fact that these are now properties allows us to say alice.age equals 20 and alice.name equals at Alice. So what a property does for us is says that since we said there is a property called age, then alice.age is, by the conventions that are now going to be like something you should absolutely follow, alice.age is underneath the hood going to be translated to Alice set age 20. And this is going to be Alice set name at Alice. So this is what properties have done for us. It's allowed us to access and set instance variables using dot notation instead of having to go through this set name and set age method or message passing. It's somewhat important, and yet at the same time not really that important to remember that we are going through the overhead of a message pass. So it's not like in regular C, this is not a struct. So you would not be able to use dot notation on a pointer to a struct. This is an object. This dot notation is calling a method, and so there's some overhead to that. But again, it's Objective-C. Let the compiler handle any optimizations. Don't really worry about the overhead of message passings. Then down here at greet, we see s.name and s.age, which are equivalent to just sname and sage. And so this is why I said before you should follow the convention that like the getter is just called name and not get name, because s.name is going to expect the getter to be called name. And if it's not, you're not going to be able to use the property as expected.
So you still need the set name, age, as functions?
Wait till the next example. Yeah.
I'm not quite getting this because you're saying that init is essential, or isn't it? Because the examples on the zip files don't have it.
I changed that. They should always have it.
They should always.
Yeah.
But it'll work without it.
So the reason for this is that NSObject's init method, so init is inherited from NSObject. And we see that student is directly inheriting from NSObject. And so because the init method of NSObject does nothing, then there is no difference between student alloc and student alloc init. Those two things are going to be the same. But you should always handle initialize object. I doubt NSObject would do this, but if someday NSObject changes initialize method to now keep track of something, then this code will break because you did not initialize that object. Or alternatively, if inside of student, I decide to overwrite the init method and have it do something, define my own init method. We'll actually see examples of that later. But if I were to define my own init method, then all of a sudden everything in main.m would stop working because I did not initialize those students. So always even if you know you're inheriting from NSObject, still initialize it. Even if it's because someone later on coming around reading your code is going to be like, wait, this isn't initialized. Now they have to go check to make sure that the initialization isn't actually going to do anything. It's always initialize. Is there one last? Okay. Any other questions? Okay. Then come here. Okay. So synthesize. This is what in the past was used to do exactly what you just said about getting rid of the getters and setters. So let's look at student 4. So we have gotten rid of the explicit declarations of the setters and getters from here, just deleted them. They were redundant to begin with. And in student.m, we have now gotten rid of the implementations of those things. In the past, you used to need to do like an @synthesize age equals underscore age messiness. The reason for that is because the compiler didn't used to be smart enough to recognize that if there's a property in here, then it should automatically be in here. Now it is smart enough. So now the property is enough to say that we want an instance variable called, well, actually, using the defaults, and this is again why we come back to underscore, the defaults of this line is we want an instance variable called underscore age that has a setter called setAge and a getter called age. And that setter and getter is going to be implemented using these particular semantics, but you don't have to worry about assign and non-atomic yet. This also means that before, even though we had said assign and non-atomic and read write, you are allowed to overwrite those. And so before, in the previous example, when we had explicitly defined setAge was not necessarily following these semantics. It happened to be because that's how we implemented it. We didn't implement it we didn't implement it caring about whether it was multi-threaded and all that stuff. So you are allowed to override these behaviors. I actually think student 5 might go into that. So student 5, looking at student.h. Again, we still have age and name. Now in student.m, we still do not synthesize, but we just happen to decide to overwrite the setName method. This was David's example of if the name happens to be David, then change it to dummy. Otherwise, do the original behavior. So here we have overwritten what the default setting would do if we just did copy non-atomic. But if we also decide that we wanted to we decided that we wanted to override the getter and say return name. Now, because of the way things are, we do need to explicitly synthesize. So now we would need to say synthesize name equals name. And those should go away. It's only if you happen to be overwriting both the getter and the setter that we need to synthesize the variable again. Otherwise, it wouldn't know that this underscore name variable exists. This behavior is because of some backwards compatibility issues, but it's the way it is.
But if you use a property, then the getters and setters are defined for you, or you have to define it?
Well, that's if you use property and you say rewrite. If it is a read-write property, the getters and setters are automatically defined for you unless you decide to override them. And if you override them both, then you need to synthesize again, because otherwise it doesn't know about that instance variable. Because like looking at student.h, we see property age and property name. We don't see anything about underscore age and underscore name, and that's part of the reason why we need to synthesize. It's messy, but rarely are you going to be overwriting both the getter and the setter anyway. You might be overwriting them if you are like trying to debug something and you add an ns log to both the getter and the setter, in which case, remember that now you're going to need to synthesize or else it'll yell at you. Questions?
So you mean like that if we change only sender or getter, we don't need to
Yeah. See, if I get rid of this line, now I'm going to get a bunch of errors. If I now get rid of this setter, I don't have any errors anymore. Because as long as I only override one of them, it's fine. It's also important just to recognize synthesize because you're going to see it in a lot of prior examples. Like a lot of online things you find will use synthesize. Because it's a relatively new thing that you don't need to use it. Okay. Okay, so init methods. So up till now, we just used init. Remember, you should always initialize something, but you don't need to initialize it with just init. You can define your own initialization methods. And if you look at, well, when you're actually doing iOS, you're going to be dealing with a bunch of other initialization methods. But the convention is that the initialization methods are always going to start with lowercase init, and then so reading this method, we have a instance method, because it's a dash. It's going to return an ID. So this is also convention. We know that it is necessarily returning a student star. And remember that ID is just sort of like a catch-all for all objects. The convention for initialization methods is that they return ID. This is pretty much the convention too, that we have init with name colon, and we pass it the name. And notice now we are passing a second argument, so space and age colon age. So the name of this method is init with name colon and age colon. That name and age are arguments. Those are not part of the name of the method. So we already see how these names can get pretty long. Believe me when I say that there are method names that are like 4 times longer than this in iOS dealings that you will be using. So there's one other, I don't remember. Questions?
The ID is something like void star.
Yes, it's very similar to void star, except it's dealing with objects instead of general pointers. And we'll see ID in other places too. And it's also similar to void star in that automatic casting happens.
Could you just go over that one more time?
This whole thing? Okay, so we have instance method. It is returning an ID, so that's just the way it is. If you wanted, you could say student star, but you shouldn't. You should say ID because any initialization method pretty much returns ID. Then the convention is that you're going to init, and then with is also pretty much the convention. Any colon, you can count the colons to determine the number of arguments to a function. So here we see 2 colons. That means we know there are going to be 2 arguments. The first argument is called name and is of type NS string star. The second argument is called age and is of type int. So when we want to actually call this function, we might say like, well, first we allocate a student, and then we say student init with name colon at Bob space and age colon 21. And we'll see an example of that in another student's 4 or 5 or whatever.
Is it possible to have multiple initializing functions name the same thing if they have different, it's like I know like in C you have constructors that are all named the same thing. If you pass different variables to them, they can do different things.
So the answer is no, but that should never be the case. Because if the variables are different, this naming scheme should be different. This is how you name methods in all method names are very long and explicit in Objective-C. And so if we decided that instead we wanted to just initialize with the name, then we would have an init with name method without the and age. If we wanted to just do name, we would have an init with age method without the and name or whatever. Yeah. That was a typo that has been fixed. These will be uploaded at the end. There are some changes. Other questions? Yeah. Yeah, we would just put more. And gender and year and whatever. It's the number of colons specifies. In theory, we don't need to say and age. Like a valid method name is init colon colon, which because there are 2 colons, we expect there to be 2 arguments. And so we can call it with like init colon Bob colon 20, but that's not what you should do in Objective-C. You should explicitly name all of your parameters. So init with name colon whatever and age colon whatever. You cannot, by default, pass in a dictionary or object or anything like that. This is pretty much the only way you can run it, unless you happen to define an initialization method that takes what we'll see later, like an NS dictionary. But that's up to you to define such an initialization method. But you pretty much shouldn't. This is the way it should be. And also, if you follow this convention, I'm pretty sure Xcode is going to give you some more advanced tips in auto-completions and stuff. The convention being this should return ID. This should start with the 4 letters init. And when someone's reading your code, they expect you to initialize something, so they should see the 4 letters init. Okay. Looking at this example, so in student.h, we see we are now declaring a new method, exactly what we saw before. Now that we have said that we are using this method, we need to implement that method in the .m file. So here, let's first look at the init with name. So this is a very common pattern. Whenever you define your own initializer, this is pretty much the pattern you want to take, where the for a second, let's say this first. So this is somewhat weird from other languages where like self is just sort of like a keyword. Here, self is a variable, and you're assigning to that variable the result of initializing your superclass. So again, this is part of the pattern that you pretty much always do. So just because I happen to inherit from NSObject, which its initialization method does nothing, but imagine that it does do something. So just because I know how I want to be initialized doesn't mean I know how my parent class wants to be initialized. So you should always call your parent class an initializer of your parent class. So the reason we assign to self and do this whole if self equals superinit thing is under some bizarre scenario where initializing the superclass manages to return nil or something, like initialization went wrong, then we don't want to do these two things. As an example, maybe we just happen to define the initializer as like only 5 objects of this class type should ever be initialized. After 5, it should just fail. And so then when they try to initialize, if it's after 5, presumably this super init is going to fail, and self will be nil, and then we'll just return self. Yes?
Is self similar to this in Java?
Yes, yes, yes. Self, this are two things you see in languages. There is no this in Objective-C. They just call it self. It means this current object. So when I have a student, like I just allocated a student, and then I pass that student the message init with name whatever, then self refers to that student I just passed the message to. And so similarly, self.age, which is also equivalent to self set age age. So self.age refers to this student. We want to set our own age instance variable to age.
Do you need to spell out the original init function or is it just calling any init with something?
Which do you need to spell out? Spell out. Oh, this? So this gets into that there should always be, and you can look up these exact words, designated initializer. So not really going to go into deep detail here, but every class should have exactly one designated initializer. And this is, in other languages, you might see it as like you define one constructor that sort of all other constructors that you have call. And so here, we decide that init with name should be our designated initializer, which means that init needs to call our designated initializer. If we then defined a id inits with age method, that should be int, then this must also call our designated initializer, and we'll use the defaults up above, John, and age. So there should always be one initializer, which is your designated initializer. And also, that designated initializer needs to call the designated initializer of your parent class. So notice that init and init with age are not calling super init. It's only our designated initializer which is calling super init. So that's just, if you start defining your own initializers, just make sure you follow this convention, and you can remember it just Googling designated initializer. And also notice that I should not do this. Why is it? I should not do this because this is not appropriately setting self. So we want to set self to whatever that happens to return, and then return self. Questions? And then going back to main, now we see that all in one line, you're allocating a student, initializing it with the name Alice and the age 20.
Sorry, can you explain why we use super
In here?
Yeah.
So imagine we are, go back to the example from a while ago where we have like NS object, then we have person, then we have student, then we have 8th grader. So I want to define a new initialization method for 8th grader. And I decide that to initialize it, like say it has an instant 8th graders, let's say kindergartner. So kindergartner has an instance variable favorite color. And so we decide that like the default value for that instance variable should be blue. So we define an initializer that says this should be blue, except if we don't then call super in it, super now refers to, if we are a kindergartner, super refers to student. And so if we don't call super in it, then we're not initializing all these instance variables that happen to come from the student class and the person class and the NS object class. So you should always initialize your superclass, similar to like you should always initialize any object that you allocate. You should always initialize your superclass. And these two methods happen to initialize the superclass by calling the designated initializer, which initializes the superclass. But again, this pattern, like this is the pattern for writing your own initializer. So you should almost always copy and paste this, and then like in these curly braces is where you set your instance variables, or NSLog, whatever it is you want to NSLog.
So I mean, we always should initialize the super.
Yeah. Because there might be something in that superclass that is like essential for everything else to work. Any other questions?
Why again is that the function we wrote? Why does it not need the super?
Why does init with age not need it? Because it's calling init with name and age. It's calling this method, which itself calls super init. Okay, we'll take the 5-minute break. Okay, so am I now louder? So now talk about collections for just a second. The only ones we're going to see right now are this NS array and NS mutable array, where NS array is an immutable array, which pretty much means like once it exists, it is what it is. You can't change it. Especially mutable array is going to be useful that we're going to be able to just keep adding things to it. NS dictionary and NS mutable dictionary. So those are going to be useful for like key value pair type stuff, associative arrays, maps, whatever, hash tables, whatever you want to call them. That's what you're going to use those for. Sets, just another example of a collection. NS array is going to be the most commonly used, and we're going to use it right here. So looking at the next example. Okay, so students.h and students.m haven't changed. It's main.m. Now we're trying to do something interesting where we have an NS mutable array of students, and we're just allocating it and initting it. And then we want to insert into that array Alice and Bob. So we've done it in one line. If we wanted, we could do the same thing. We could do boom. So the NSMutableArray class defines an instance method called addObject that is just going to take some argument with type ID. And so since student star is an object type, that is an appropriate ID. And then we're going to do that again with Bob. So you can think of this as an array where the first element is Alice and the second element is Bob. And then here is, I referenced this a while ago, that we have this for in syntax that we're able to use with collections. So this will also work for dictionaries and sets. So for each student in this NSMutableArray, we want to greet that student. So one thing that's somewhat important to remember is that everything inside of this array is just stored as an ID. Like, there's nothing enforcing that I only put students into this array. If I wanted, I could put a student and then a string and then another student and then some UI table view controller. It's up to you to enforce that everything is of the same type. Or if you don't want to enforce that, you need to just make sure it makes sense, you know what you're doing. But like if I wanted, I could say this, and this isn't going to work because NSString doesn't have a name and age instance variable, but it doesn't know what's inside of the student's array. So for all the compiler knows, it is an NSString. This is where it can be somewhat dangerous dealing with ID. And this is also why you might need to be dealing with casts. So you might want to cast these return values to the appropriate things. Okay, so questions on this iterating over an array? Yeah?
How does it know like what order to iterate over, or
So how it's working underneath the hood is that this NSMutableArray class needs to define how to iterate over it. And so in this method that it's defining for how to iterate over it, it's saying that like I'm going to do it in this order. So it's saying that like index 0 is the first thing that should be returned, then index 1, then index 2.
is there any way to add generics to it? Like,
So we'll see. I don't think there is directly to arrays. We'll see, though, that protocols, at the very least, are ways to make IDs a little stronger. They're ways to make sure that these IDs are at least objects that conform to a specific interface. I don't think there's any generic type construct in the language. Okay. Okay, so that's the syntax we just saw. And notice here we are saying for ID foo in bar. And so we don't know what is inside a bar. And so all we can really say is ID unless you happen to know what it really is. Okay, so categories is actually, let's ignore that for a second. Let's do another example first. Students 8. Okay, so the point of this example is I've decided I don't want to print these things in just whatever order I happen to insert them into the array. I first want to sort the array, and then I want to print out the sorted array. So there are a couple ways we can do that. I inserted them in the order RJ, Chris, Rob, David. So here, by looking at the NSMutableArray documentation, I see that it has a whole bunch of different ways of actually sorting things. One way is this sorted array using selector syntax or method. First, let's look at student.h and student.m. So inside of student.h, I've defined a new method called compare. It's returning this NS comparison result, and the only reason that's relevant is because this sorted array using selector method expects a method to be passed to it that returns an NS comparator result, whatever it is. So this compare method is going to take another student and just compare our current student, with that student. Looking at the implementation of that, I decided that I'm just going to compare by name. So I'm going to use self.name references the NS string that is my name. And then I'm going to compare that, like the NS strings compare method, I'm going to use that to compare to the other student's name. And because this compare method returns an NS comparison result, that is an easy way of making sure that I return an NS comparison result. Okay, so now that I've defined this method for students, I'm now going to say here that I'm going to sort the students array using the selector compare. So this special syntax at selector, remember that methods and selectors are kind of like interchangeable words almost. So I can't just say like this, because that's not really a valid syntax. I want to say that I want to use the method compare colon. And so to actually specify the method compare colon, I wrap it in this special selector keyword. And so what this sorted array using selector method is going to do is iterate over this students array, calling the compare method of each student to say like, okay, student 0 and student 1, how do you compare to each other? And then like depending on how they compare, it's going to determine whether student 0 belongs in front of or after student 1. So compare has to exist for everything in this students array. And then let's just run it to make sure that's the case, that this works. So we see it prints Chris, David, RJ, Rob, which is what we wanted.
So the compare function is like preset, like to how do you compare different strings?
So how do you in here? If we could also decide that we just want to compare ages. This isn't quite right because they're ints, and I'm not sure of what NS comparison result looks like. It might just be like return self.age less than other student.age, or I guess maybe like if 1 is less than, I'm supposed to return 1, or if they're equal, I return 0, or else -1. I'm not sure what NS comparison result is supposed to look like. Actually, so another, let's go to here again. So a useful syntax that we've already seen this useful shorthand for defining an NS string, this blah, 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 with the @ in front of double quotes. Another useful syntax is an @ in front of brackets for shorthand for defining arrays. So, and NS arrays. So now I've defined an array, an NS array with 2 objects, hello and world, 2 NS strings. An additional shorthand that's somewhat useful is @ in front of any number. So this defines like NS string was the first one, NS array was the second one. This defines an NS number with the value 42. And so what may or may not work, what I'm going to try right here, no, actually that won't work at all. So I might be able to do init NS number alloc. I just want to see if this ends up working at this point. Init with int self.age. Oops. And then I want to compare that. Does it have a compare method? Compare to another NS number, which would be NS number alloc init with int other student age. Okay, so questions on what I just did there? Yes?
You didn't use the selector on the compare.
So I'm not using, Here, I'm just defining the compare method. It's when I want to actually reference the compare method that in here I say the method I want to use is compare colon. And this is again what I said before, like the literal name of the thing includes the colon. So here I'm referencing the method compare colon. In the definition of it, I don't need to use @selector.
But whenever you want to pass a function to a function, you have to use that selector.
A method to a method, yeah. Because if it were a function, I wouldn't need to use @selector. I could literally just use a function pointer, but you don't need to deal with those here. There's probably some spacing error here. Oh, but that's because I don't need this. Whatever. That's the general idea. So that's that. Questions before I move on to a similar idea? Yeah. And just as, remember, it's like C where this, in order to get the prototype for this thing, I can literally just like copy this, paste it, and put a semicolon at the end. So the prototype is just the first line of the definition of the function. Okay, so that's that. And now going to students 9 is where we're going to get into categories, which that's not very helpful. So here, okay, so the idea behind categories is notice that in order to do what I just did, I needed to actively modify the student class, which is fine because I'm the one who created the student class, so it's fine for me to go into this student class and add a compare method. But what if this class that I need to modify is not something I have access to? What if it's in some compiled library, or it's one of the foundation classes or an iOS class? I need to add a method to it, but I don't have access to the source code. So these are what categories are for. They're for extending existing classes. And so in Xcode, you can actually do this like file, new, file, and then category, and it'll like walk through the steps. And the default format of these categories, so remember I'm working under the assumption that I don't have access to the student class. So the default format of these file names are student, which is the class that I am extending, plus, and what I happen to call the category. So here, I am extending the student class with the category student compare. And this is just a syntax that you're free to look up whenever you happen to need to extend a class like this. So this extension of the student class is going to include this method. A category is not able to define instance variables. It's only able to define new methods for a class. So looking at the implementation of this category, again, it's the category itself is student compare, and I'm extending student, and I'm implementing it basically how I implemented it before, exactly the same, except I'm able to do this without ever touching the original student.h and student.m. And this will work exactly the same. Now in main.m, instead of importing student.h, I import student plus student compare.h, because student compare.h is what is importing student.h. And everything else in here is the same. Yes? Oh, main, okay. Oh, these angled brackets and quotes. So the angled brackets refer to like these special directories in the file system, in the operating system that it knows to look in to find these files. So like foundation/foundation.h is in one such special directory whereas these double quotes are what you're going to want to use to refer to files in your current project. So in this project, I have a student plus student compare.h file. Double quotes is like relative to my current location, whereas angled brackets automatically goes to these special directories. Yeah.
You can add addendums to existing, like for example, like if there was another like file system, or I'm sorry, like something to the extent of foundations, but you wanted to add an addendum to that, you would use that syntax for doing that as well, or?
Do you mean by addendum, do you mean like this sort of stuff, this category stuff?
Exactly.
Oh, then yeah, so in student compare.h, well, let's say student.h was a foundation class. Then I would do foundation/student.h. And inside of main, I would still do student plus student compare.h. I wouldn't import the original foundation version of things. I would import my version of things that have been overridden.
What you're doing with this external student.h is you don't inherit it, but you do a wraparound, right?
Yes, it's actually just an extension. It is the same class, and anywhere else in your code that uses that class could also use that new method. If it doesn't happen to hash import the correct category file, the compiler will complain that like it doesn't know that method exists. But that method now actually exists for that class. Mm-hmm.
Where's NS comparison result coming from? Is that a library?
So that's something in foundation/foundation.h. We could actually just look it up. NS comparison result. So something about the Apple documentation is that it can be overwhelming, but it has a lot of good examples. So feel free to ask questions on like the message board if you just find yourself lost in a path of various methods and stuff. So data types, what was I looking for? NS comparison. So it looks like NS comparison result is, all right, this syntax you don't even know yet. Let's hold on for that. That's going to be the next thing. But NS comparison result is just something that Foundation defines, and that's why I wasn't 100% sure what it is. I just know that the compare methods of NSString and NSNumber also return NS comparison results, and so that's what I used. But if you wanted, you can construct your own NS comparison results to return. Okay. Questions before the next thing? So, next thing is this. Again, I think the slide's going to be worthless. So blocks. So that's the general format of blocks, but that's worthless. So looking at the example of using a block, Okay, so back to student.h and student.m. I have not modified them to include a compare method. I've not added a category to extend the class. Instead, I've used what's called a block. So a block is kind of like an anonymous function in other languages. It doesn't even have to be anonymous. If you wanted, you could assign it to a variable. It's kind of like, if you're familiar with the term, it's like giving Objective-C first-class functions. So like in Objective-C, I'm not really able to just define a function in the middle of this method. That's not entirely valid. Whereas I am able to define a block. So just like in JavaScript, you saw a syntax like this. Here, we are using a different method. So before we used sorted array using selector. Now we're doing sorted array using comparator. And so this comparator expects a block that this little caret symbol specifies that what is following this is a block. And this is the return type of the block, NS comparison result. This is the two This is the type of the first argument, this is the type of the second argument. And I know this because if I look at the documentation for sorted array using comparator, its argument is supposed to be a block that returns an NS comparison result and takes two arguments that are both IDs. So this I got directly from the documentation. And then I need to define the function itself. So I have my little curly brace. And in here, I'm doing the same sort of thing I did before. We see here that I cast A to a student star. And that's because in here, A is just an ID. And here, B is just an ID. So if I actually want it to be a student object, I first need to cast it before passing it name. So student star A name, student star B name gives me these two names, and then I use the NS strings compare method. So I don't have to construct my own NS comparison result. And we know that this appropriately returns an NS comparison result like this says it should. So blocks anonymous functions. The syntax is a little strange, but it's convenient that like I don't need to define a method in the student class just to sort this array, which like that was a very heavy-handed result just to get a sorted array.
Can you assign the block to a variable?
Yes, so that's where, I'm not going to remember the syntax, but it's going to look something like, so it's something like what it returns, and then in parentheses what I want to call it, and then ID equals, and then pass it to here. Didn't complain. So if you're familiar with function pointers in C, I just sort of used that same syntax. I replaced the star with a caret. So here is, we are defining a variable called func that is a block as indicated by this caret. This is the return type of that block is NS comparison result. The arguments are two IDs, and we are assigning that to this block. And then we're passing that variable to that function, to that method. Questions? Okay. So, a couple last things. Okay, so protocols. We're not going to go into deep detail today about them, but they are going to be pretty substantial in your iOS usage. So the syntax for this, remember that, well, inner interface, we would also say like :NS object, but here, this angled bracket syntax is how we're going to specify that it must adhere to some protocol. And so the NS copying protocol, this is where I'm saying a protocol is kind of like interfaces from other languages. By saying that the student interface implements the NS copying protocol, I'm saying that it must implement the methods that NS copying says. Anything that implements me must implement. So looking at the implementation now, if we look at NS copying, it says that you must implement a copy with zone function method. And so here's us implementing it. You don't really have to care about the syntax of it for now or what it actually is doing. So the idea is that since student implements the NS copying protocol, it must implement all methods that NS copying says. And the use of this, as we see, is going to be like a lot of these functions that, or a lot of like classes that you're going to be using with iOS, like a lot of these drawing classes are going to expect you to pass it objects that must adhere to certain protocols. For example, UI table view is one. Let's actually look at documentation. This documentation will work. Okay, so we see in the documentation that, let's look at data source. So UI table view is in like your iPhone, it would be like your contacts list sort of. It's just like a bunch of rows with data in them, and you can scroll up and down on it. So here, UI table view defines a data source property where the type of that data source is just an ID that implements UI table view data source. And so this is important because if you then set this property to be some object, that means that that object must implement this protocol. What this protocol says must be implemented are, so some methods are optional, some are required. So these two methods are required. And so when you set that property of a UI table view with some object, that object must have these two methods that say like how many rows there should be in this table, in this section, and also what should go in each particular cell. So when you try to create a table view, you need to pass some object that is capable of populating the cells of that table view. And so in UI table view knows that you are capable of doing that if you implement the protocol. And you'll see that that sort of pattern is going to be pretty common with a lot of things you do. Questions with protocols? And that's really why, like, if you compare it to like a Java interface, protocols are much more similar to those, since like protocols almost define a new type, kind of, whereas like an interface in Objective-C is just a list of all the methods that you implement. It doesn't say anything intelligent about like, okay, or well, really what protocols allow are like multiple objects to all multiple classes to all fulfill some common purpose. So as long as like, an example are all these like enumeration classes, the collection classes, NSArray and NSDictionary and all those. As long as you appropriately implement some protocol, then you are able to use the fast enumeration syntax on that object, the for-in syntax. And again, much more of that to come. Just so you've seen it, NS exceptions. This is very similar to some other languages with try-catch blocks, and we also happen to have finalies. So that's just know it exists. You probably won't even use them that much, but it's useful to know. NS error is somewhat of an alternative. So instead of having to use like the try-catch finally syntax can be somewhat large, especially if like each one of those do something here is like a single line, then you've sort of like wrapped it with 3 times as many lines as are actually accomplishing something. So this sort of syntax, this is one of the rare scenarios where you are going to be using ampersand still. So again, we're never dereferencing an object, but we are passing the address of an object. We are passing the address of this NS error so that if something happens to go wrong when we pass the method bar, the method is called bar : error : so when we pass the method bar : error : to foo, if something happens to go wrong, then foo will instantiate an NS error object and set E to be that NS error object. So inside of here, if something went wrong, E will not be nil. If we just passed E, then inside of this function, this method, it would have to dereference E, which is something you shouldn't be doing. You should never dereference an object. Plus, if you tried to dereference E, you'd be dereferencing nil.
Return value of the whole thing is now the error. So that's why you're comparing it to nil.
So it will, by returning nil, it's indicating that something went wrong. And then inside of here, now, since something must have gone wrong, E must be set to something that isn't nil. Okay. Inside of the function, it must have instantiated an NS error object and did like star E equals this NS error object.
The function pass has to return nil.
Well, the function or the method is bar error, bar colon error colon. But if something goes wrong, yeah, that's just like when you read the documentation, it'll say like, if something goes wrong, nil will be returned and error will be set to some NS error. So it's also possible that it will return void, and then it's up to you just to see if E is still nil, and that's the way you know there was an error. But that's just, in this example, we say nil is returned on error, and what that error was is inside of E.
It's not like a try catch in Java.
Yeah, it's not. So instead of just failing, we just put it inside of E. But other things do use the try-catch syntax. So some things don't have this. All right. Any other questions? I think that's it for our Objective-C intro. If there's anything left, it was a lot. But up till we haven't really done any iOS stuff, so we'll throw all that at you next week.